Thank you, Kathy, and good afternoon, everyone. I am Lola Infante, Executive Director of Government and External Affairs at EPRI, the Electric Power Research Institute, and I will be moderating our panel today, as Kathy just said. I want to start by welcoming everyone to this EPRI and Hydrogen Forward event on feedstocks for hydrogen production. Today's webinar is a follow-up event to an overview of the U.S. hydrogen landscape that we had back in December. Available to watch. We can put the link on the chat in a few seconds here. My team will do that for us. Today's webinar is also the first of a three-part series that will explore all aspects of hydrogen hubs. On April 19th, we will explore the storage and transportation of hydrogen. And on May 10th, I think that's the right date, May 10th, we will take a look at hydrogen applications, the decarbonization of industry, transportation sector, and of course, for power generation as well. So I really hope that you will all join us for those sessions. I also invite you all to ask questions on the chat. As Kathy just mentioned, we'll try to address them throughout the conversation today and also at the end if we have time. To make sure that the chat functions works, why don't we just give it a try? If you can all type what you think is the most important barrier to the deployment at scale of hydrogen, whether it's markets, policy, technology, cost, whatever you think the main barrier is, just type it away. One word is enough. I'd love to see what you all think about this. It'll be fun to see your responses at the end. While you're all busy with that, I'd like to thank Jeff Begdell and Lexi Ryan and the whole Hydrogen Forward team for their partnership and support of this series. They have been fantastic partners, and we look forward to continued collaboration with them on this series and beyond, of course. On the EPRI side, this event is supported by the Low Carbon Resources Initiative, LCRI, which is a 5-year global collaboration between EPRI and GTI, the Gas Technology Institute, that was created to accelerate the commercialization and deployment of hydrogen and other low carbon resources. We have over 50 members from electric and gas utilities, as well as OEMs and other stakeholders that have all contributed to over $130 million in funding to accelerate research, development, and deployment in the whole value chain of hydrogen and other low carbon fuels. Here too, we'll post the link on the chat in case any of you is interested in learning more about that. I am really looking forward to the conversation today. As you all know, the infrastructure law, the IIJA or infrastructure bill, whatever you want to call it, has $8 billion for clean hydrogen hubs. Now, what clean means and how we're going to produce hydrogen is a major topic of discussion here in the US and abroad. Our sensational panel today is going to help us understand the different feedstocks and technologies that we can use to produce hydrogen, the differences that may exist across the regions of the country and globally. And because they're all actively participating in hydrogen projects as we speak, they will share their experiences and learnings with us. I'm very excited about this. So let me introduce our panelists. After I say all of their names, I'd like for each one of them to give us a 1-minute introduction of themselves. So today we'll speak with Kathy Ayers, Vice President of R&D at Nel Hydrogen, Neil Biop, Head of Global Government Affairs at Linde, Stephanie Curran, Business Development Manager of Energy Transition Solutions at Equinor, and Colleen Wright, Vice President of Corporate Strategy at Constellation. So Kathy, would you like to start? Just 1 minute about who you are and what your company does?
Sure. So Nel Hydrogen has been in business in various forms for close to 100 years at this point. We have the Connecticut facility that's been there for 25 plus years making proton exchange membrane electrolyzers, and the facility in Norway making alkaline electrolyzers for close to 100 years. I'm the Vice President of R&D, as you mentioned, and I've been with the company about 15 years in charge of our technology roadmap for bringing down the cost and increasing the performance of the stacks.
Thank you. Neil? Alphabetically.
Thank you, Lola. So my name is Neil Biop. I head the Global Government Affairs function for Linde. Linde is a global industrial gases company that's been producing hydrogen for well over 100 years. We are, I think, the world's largest liquid hydrogen producer, and we are a provider of both hydrogen molecules and hydrogen-related technologies as well. So I am based in Danbury, Connecticut, at our functional headquarters here, frequently back and forth to Washington, D.C., but we also have offices in Munich and Berlin, Germany, as well as elsewhere around the world.
Wonderful. Thank you, Neil. Stephanie, you're up.
Hi there, Stephanie Kern, Business Development Manager with Equinor Energy Transition Solutions. And I'm located in our West Virginia office in the tri-state area, West Virginia, Ohio, Pennsylvania. And Equinor is a Norwegian-based broad energy company. We have oil and gas production, as well as we're heavily involved in renewables and low carbon solutions, where this is where hydrogen and CCS live in the Equinor world and low carbon solutions, which is what I'm involved in. And we have, we're working with some partners in similar hydrogen hubs in Europe, in the UK.
Wonderful. Thank you. Colleen.
Hi, thanks for having me today. I'm the VP of Corporate Strategy at Constellation. Constellation is about 2 months old, but we just went through a corporate separation with excellence. We've been around much longer than that, just as part of another company. So we went live with trading about 2 months ago as the leading clean energy provider, largely driven by our nuclear power plants and our nuclear fleet, but we also have a diverse set of clean supply resources. And then we also have the leading clean energy products and services company that serve customers.
Wonderful. Excellent. Thank you all so much for being here with us today. So let's jump right into it. Let's start at the very beginning with a discussion of what clean means. It seems like it should be an easy answer, and yet somehow it is not. Again, the infrastructure law here in the US, the IIJA, kind of gets into it, but doesn't prescribe any specific technology. It really only mentions hydrogen that is produced with carbon intensity equal to or less than 2 kilograms of CO2 per kilogram of hydrogen produced. Neil, this is for you. What does all this mean? Why is this definition important, or is it important at all for the development of the U.S. hydrogen industry? And then, do you foresee any challenges to meeting this standard?
Yeah, so the all of the above approach that was prescribed in the infrastructure bill is really, really important. The market for hydrogen is to some degree well established in the industrial space today, but as you look at the other sectors for which hydrogen has a myriad of applications in the energy sector or transportation or mobility sectors, that market has to grow. And so having an all of the above approach with a target for carbon intensity for industry to chase allows for technologies and costs to kind of get to the right levels in order to encourage the market to actually grow while we're decarbonizing what we consume today. So it was really encouraging, and I think thoughtful that the law encouraged that all of the above approach. It allows for us to decarbonize what we're producing today in a very economical, feasible way, and get immediate emissions reductions while also allowing that kind of demand side technology adoption to start to happen over time. And we've seen that be a hurdle for various industries in the past, but this allows industry to chase a goal that I think we all share of decarbonizing over time. And so we're really excited about this. Technologies also change over time. We've seen, I know with Nel, for example, they've stated some interesting goals to address efficiencies and costs over time. We don't necessarily know what the most efficient and practical method of producing hydrogen is going to be too far down the road, because you've got to have a significant adoption of renewable power, which isn't always available everywhere today. And you've also got to figure out how to distribute and consume these cleaner molecules. So we're really excited about it, about the approach that they took, because I think kind of providing that goal for industry is the best way to encourage good behaviors and technology advancements, rather than being very prescriptive in the technologies. That said, there are challenges with it. It's a very ambitious goal of 2 kilograms, and I think in terms of carbon, I think ultimately, that's an okay thing to do because we've got to be able to get those costs down at the same time. The cleaner the molecule today, the more expensive it is, and that's a kind of an economic balance that industry needs to address and achieve, and it makes a lot of sense to create a stretch goal so that we are actually achieving our environmental and societal goals while we are trying to encourage a growing industry and a growing market here. So. We're excited about it. I think we're very clear-eyed on what the challenges are going to be. But as you can see from all the stakeholders we have on this panel today and everybody that's joined us, just some very, very innovative, thoughtful, and capable group of folks all striving for the same goals here. So we think there will be again some ups and downs with it, but certainly achievable and certainly in line with where we need to go as a society.
That's great. So actually cost, I just was glancing at the responses from the audience, seems to be the one topic, the one barrier that comes up more than the other ones. So related to this, obviously there's a lot of talk about electrolyzers. The infrastructure law, again, is devoting a lot of money to this technology, and DOE has an aggressive goal, very aggressive goal, I should say, to reduce the cost of hydrogen. I think it was 80% to $1 per kilogram in the next decade or so, I think. So Kathy, I know your company is doing a lot to make this happen, actually. You're one of many walking the talk. You announced last year that you would reduce the cost of electrolyzers by 75%, if I got this right, and wanted the cost of hydrogen to drop to $1.50 or so per kilogram by 2025. So that's kind of like around the corner. Tell us more about this. How significant is this goal? What factors will affect the cost of hydrogen? And perhaps more importantly, what factors will make electrolyzers competitive with other production methods or other fuels for that matter?
Yeah, so that total cost of hydrogen of $1.50 or DOE's goals of $1 obviously involve both the capital expense of the equipment and the operational cost, which would be the electricity cost. So the low-cost renewables do certainly help enable that pathway, but there's also a lot we need to do on the electrolyzer side to both increase the efficiency and decrease the capital cost. So a lot of the things in our roadmap have to do with using less material, going to thinner electrodes, converting from more traditional processes to more high-speed automated manufacturing. And we see a lot of opportunity for those things because electrolysis is still less mature from a manufacturing perspective than fuel cells. So even though the technology's there, it's been there a long time, it's reliable, we just haven't come down the same cost curve that the PEM fuel cells have. And so there's a lot of room for us to do that. We also see how different scenarios are going to have different solutions. So there may be cases where your low-cost electricity is not there as often, and so your capacity factor is lower. That means that your capital cost has to be particularly low in those areas. So, I mean, I think as Neil was saying, there's going to be different solutions for all different regions. Maybe it's high temperature electrolysis, maybe it's low, maybe it's something else. And we have to look at the problem holistically to figure out what's going to be best. But we do see lots of opportunities for electrolysis to meet those needs.
Wonderful. Before we leave this conversation about cost or carbon intensity, do any other panelists want to jump in and say something about this topic?
It's Stephanie. Yeah, I can probably add a couple of words. The hydrogen hub that Equinor is pursuing is a blue hydrogen hub. So carbon intensity is a topic that comes up a lot for us. And it's important to look at the natural gas production, the processing, and the transport. And there's actually few really complete and updated analysis around that cover the entire blue hydrogen value chain with best available technology for the process facilities, as well as the proper design, operation, and maintenance. Equinor has been looking into this both for our European hydrogen hubs, and so in terms of gas export from the Norwegian continental shelf, as well as the Appalachia region. And what's interesting for Appalachia is the I guess the variety of GHG intensities we see from different producers and different transportation infrastructure, and the driving in terms of the processing, transmission, and compression as drivers for intensity for blue hydrogen production there. So location of the reformer is a key aspect in terms of reducing GHG emissions, as well as the ongoing reduction measures we see within the industry to improve the intensity or CO2 emissions from transportation will be important for the blue hydrogen sector.
Fascinating. So we're talking about colors here. So Colleen, let me ask you this. So renewables are the obvious clean electricity source to produce hydrogen. That's what comes to mind first for many folks. But there's also nuclear, right? In fact, there is increased interest all across the globe in nuclear power as a source of baseload zero carbon electricity generation. There is also a lot of talk about using nuclear electricity to produce hydrogen. So tell us more about this relationship, these synergies that nuclear power and hydrogen seem to have. Is this a match made in heaven, as some may say?
Yeah, we certainly think it is a match made in heaven. You heard Kathy talk about the value of the capacity factor associated with the production of hydrogen, and that's something that really adds a lot of value and synergy between nuclear production and hydrogen production. So in nuclear, we have 24/7 assets. So the ability to run those assets 24 hours a day, 7 days a week, and pair those with electrolyzers makes nuclear today the most cost-effective form of hydrogen production and also the lowest carbon intensity. So we measure carbon intensity using the Argonne GREET model, and that consistently shows that nuclear would be the lowest carbon intensity based on that 24/7 operation. In addition, the steam from the nuclear power can also be used to both increase the efficiency of the hydrogen production through electrolysis when high temperature solid oxide electrolyzer technology is used. And then it can also be leveraged to increase the economics of the end uses that may require steam integration. We also have siting and permitting advantages associated with nuclear produced hydrogen, and the integration of hydrogen production can also help ensure that these valued assets remain online to support the clean energy transition and continue to use those clean megawatts to support the decarbonization of what is traditionally harder to decarbonize or harder to electrify sectors. So lots of different value for nuclear produced hydrogen. And we're really excited about the inclusion of nuclear in the hub and the explicit call out of it. So.
Wonderful. Any thoughts from any other panelists about this? Colleen just said?
Well, I can just reiterate because I think it's in line with what we view as some of the challenges with the short-term prospects for electrolytic is that we don't have enough clean and renewable power to leverage that quickly, and I think this all of the above approach with nuclear makes a whole lot of sense. I think we agree with it on a global basis as well as in the U.S. I mean, there are parts of the world, as was said before, where certain applications are going to be the right one, and I think we view nuclear as having a very significant role and opportunity here in getting us down this decarbonization path.
That's awesome. Anybody else before we move on to the next question?
Yeah, I think we'll talk a little bit more about the hubs a little bit later, but specifically on the nuclear question, I mean, we agree. Obviously, we're doing a project with Constellation now, and really trying to understand, each other's language and what each other's requirements are, so that we can really show the integration of the two and demonstrate it at scale.
Yeah, and just to Kathy's point on that, there are a couple of different DOE-funded demonstrations integrating electrolyzers with nuclear technology across the country right now. One of which we're doing with Nell up in New York, but the demonstration and the ability to integrate electrolyzers with nuclear is not something that's brand new, something that we've been exploring and we think is scalable.
That's great. Looking forward to see what you guys come up with. So we go back to Stephanie for a second. Obviously, you mentioned you work at Equinor, which is a major oil and gas company, also committed to renewables, hydrogen, CCS. I know Equinor is part of the initiative to develop a regional hydrogen and CCUS hub in the Ohio River Valley. Tell us more about this hub, especially the hydrogen production part, and also about the collaboration that is going on and why is this important and what we're trying to achieve there.
Sure, thanks, Lola. The Ohio River Valley region is very uniquely positioned in this regard to become a regional hub for blue hydrogen and CCF, given its vast natural gas resources and very high concentration of diverse end use sectors, including heavy industry, steel, iron, coal manufacturing, petrochemicals, and power generation. So the envisioned hydrogen and carbon capture storage hub is based on connecting those industrial and power plant users to a hydrogen supply and carbon dioxide offtake and storage infrastructure. So the first project will have the capacity, hydrogen production capacity, to meet that initial demand of end users who are the first movers. But then over time, the infrastructure will be expanded to integrate more end users, including those in other sectors over time, such as road, freight rail transport, and then potentially integrating renewables. So essentially, the first project kickstarts the local hydrogen economy, and then we scale from there. Collaboration is key in the development of this new energy system. There's no single company that can do this alone. It's a huge endeavor. Over the past year, we've been analyzing the tri-state decarbonization opportunity and evaluating the hydrogen and CCS project options. And we've worked to establish a consortium of hub investment partners and demand end users. To date, we do have memorandums of understanding with key industrial players in the area. And as you mentioned, we're a founding member of the Intermarket Regional Decarbonization Alliance. And we're also collaborating with Battelle, evaluating the storage potential in the area. So all these perspectives, whether it's investment partners, end users, technical and engineering experts, local governments, stakeholders, national laboratories, government departments, they're all really important to design a successful hub solution that delivers safe and reliable hydrogen and carbon dioxide storage, reduces carbon emissions, of course, and provides good jobs that are sustainable over the long term. In terms of opportunities, I mentioned that the first project is going to kickstart the hub with the growth and add additional end users over time. And this allows the decarbonization beyond the energy sector, supporting industry to decarbonize and remain competitive both nationally and globally. And in our UK hydrogen hub that Equinor and their partners are developing, I recently listened to the local business association speak about that hub, and they were talking about their anticipated growth in the area of industrial projects and industrial users because of the availability of clean hydrogen and CO2 storage. So there's tremendous opportunity available here.
Thank you, Stephanie. Staying on the hub conversation, and also just a couple of questions I saw here on the chat about, other than nuclear, what other technologies have the ability to really truly take hydrogen production to the next level at scale to get as much of this resource as we potentially will need. Neil, this is for you. I don't know that I'm going to make a lot of sense putting all these things together, but you'll help me out here. Lindy has a significant hydrogen footprint in the Gulf Coast. You're also a founding member of a large alliance to develop a carbon capture and storage hub in Houston. How is that going? What barriers remain to CCUS? Is that potentially another of these technologies that will help produce as much hydrogen as we potentially will need? Can it compete? How is that going? How is the CCUS world evolving?
Well, it's evolving. I think it is certainly in part driven by supporting policy frameworks at the federal level, and we've seen some discussion of potentially increasing some of the benefits for CCS, CCUS that will actually make the economics work a little bit better. Right now, capital costs and operating costs, for that matter, are really well above what the government incentives provide for today. So we do think there's opportunity there to help spur the market in that sense. But that said, the Gulf Coast is probably one of the best places for carbon capture and storage. The geographic area has been so much explored by the oil and gas industry. We know that based upon the characteristics that it is ideal for carbon capture and storage. It's not the case everywhere across the country or everywhere in the world. Geology plays a big part in the viability of carbon capture and storage. So the Gulf Coast makes a lot of sense for that reason, because it is so well known, so well explored, and has the geological characteristics necessary for that. And so given that we do have a very significant hydrogen footprint in the Gulf Coast, we have already a lot of infrastructure that exists in terms of both the generation and the pipelines. When you put that together with the carbon capture possibilities down there, it really does kind of allow us to hit the ground running for a potential hub in that region of the country. And it's significant because we have the ability to decarbonize immediately and never break any kind of production or supply to customers as they decarbonize. So you have the ability to have a seamless decarbonization with existing operations serving a whole myriad of industries already today. And it does capture both the production, distribution, and the consumption components of a hub already. So we're really excited about the potential for that, given the concentration and the need to really start to decarbonize. You hear a lot about the hard to decarbonize sectors, and that's what we're talking about on the Gulf Coast. So we have the ability to do that right now. If we can get the economics in order and we can get some kind of critical mass and economies of scale, we think that's going to go a long way down there and help. And again, another perfect example of where one solution in one part of the country is different and maybe even on a different pace than what may be applicable in another part of the country. And I think that's one thing that we've talked a lot about as we've contemplated the various regions and potential hubs, is that they're not all going to require the same amount of public funding. They're not all going to move at the same pace. They're not always going to have the same technologies either. And that kind of flexibility, I think, is inherent in the law as it stands today, and is something that I think needs to be remembered going forward.
That's a great point, Neil. So Colleen, Kathy, Stephanie, any thoughts about this, regional differences, what can be done in each part, hubs?
No, nothing substantial to add. I think the unique geographic characteristics in different regions of the country are going to lead to very different solutions from a hub perspective. And as Neil talked about, there's just going to be a diversity of opportunity to support the industry. And it's we really need an all of the above solution to achieve our decarbonization goals as a country.
Yeah, I completely agree. I think we get too hung up on, is it this or that? And we need all of them. They're all going to make sense in different places under different scenarios. And I think all of us in different industries have to look at the fact that we're all going to have many opportunities, to scale our technologies and to deploy them without sort of saying, well, that other technology isn't going to be suitable. So it's going to take all of them, and it's all going to be big.
And one closing comment from Stephanie. I agree with the all of the above, the need for the all of the above as quickly as we can. And I mentioned CCS in my discussion about the potential tri-state hub. And we're envisioning a clean energy hub, so that includes hydrogen as well as a CCS service. And that integrated business, it provides a more economical solution where you can utilize the infrastructure for both CO2 storage infrastructure and transportation infrastructure for both your hydrogen storage, CO2 storage, as well as a separate CO2 storage component. So you get to decarbonize more end users and use your capital more efficiently. So in this case, I see those two as integrated businesses.
It's fascinating. Thank you, all of you. Again, I can't wait to see what happens in the next 2 to 5 years. It will be interesting to see. So changing gears just a tiny bit and move towards the network aspect of the hub. Kathy, I'll start with you. As an illustration of this network concept or idea, what about refueling networks? I know your company, Nell, is working with other industry stakeholders to develop transnational hydrogen refueling station networks. Tell us about why is this is important. What is the link, if any, to the hydrogen hubs or industrial hubs for that matter? Does it fit?
Yeah, I think it definitely fits, and I think the hub concept will help to enable that because I know there's multiple hubs that are talking about transportation as one of the hydrogen use cases. Back to the all of the above, a common question is, battery vehicles or fuel cell vehicles, and I think it's going to depend on what type of vehicle and where and what is the network. So it's very difficult to establish the network from the ground zero just for passenger vehicles. Things like heavy duty vehicles make a lot more sense because you have trucks and buses driving the same routes every day, driving to the same depots. And so we've started that effort with selected stations in a few different areas, but I think the hubs can really help enable the connectivity of those. And then we'll see where that goes in terms of more of the passenger vehicles as well.
That's great. Thoughts from others on best use cases and hubs? Is there something there that we should explore?
Well, the one thing I would say, if I can, is there's a little bit of a chicken and egg, well, a big chicken and egg issue we have here, and when we look at the various hydrogen applications, making sure that we are simultaneously driving demand while we are driving new production methodologies or sites is really, really important here. I think a lot of the within the industry, we look at what we can do from a production or a distribution perspective, but we can't lose sight of the fact that the demand has to be there, and we have to know what that is going to be, at least to some degree, so that we can plan for it and scale it. So, as you just said, when you're talking about a passenger vehicle versus a heavy duty long haul trucking, very, very different dynamics, very different economics and considerations. And the fact is, the long haul duty folks are looking at the price of diesel versus the price of hydrogen, right? They're not necessarily looking at different production pathways of hydrogen. They're not necessarily looking at other variables as much as they're looking at straight costs sometimes of things outside of our industry. So we have to compete with all these other variables out there and also get a sense of where the market is headed at some point. And we think there's a feasible and rational way to do that, but it does take some time. And I think in the conversations I've had, it kind of requires all of us to pause a little bit and really think through where these clean molecules are going to go and who wants them.
Yeah, and that point can't be overstated, that demand is a product of economics. So if the cost of clean hydrogen is such that it makes it challenging to decarbonize and replace or spur the development of the transportation network, we'll have to find solutions to that long term if there's not sort of policy support in the near term. And the policy support from the hub doesn't necessarily get at the cost of end use consumption for the hydrogen. So the spurring and the development of that transportation network long term is something that we really need to focus on. There's a difference between kind of the drop-in potential of existing end-use customers and then the creation of an entirely new market. And we're making great headway in the transportation market for heavy-duty transportation. And I think that's, Kathy, I agree with you. That's really where the focus is from a hydrogen perspective. We have a long way to go.
Anybody else to jump in? Stephanie, I know you're working with the steel industry. There's a question about that. Any insights or lessons learned about that?
No, sorry, I must have missed that question in the chat. But of course, that's a sector that's one of those tough to decarbonize areas where hydrogen's particularly interesting. So that's and steel production, of course, is present in the area in the hub that we're looking at, and one of the key end users.
This is Interesting. What about existing gas networks, though? Stephanie, you again, you have a number of projects globally looking at converting the existing gas network. What can you tell us about it? Is there any lessons learned that we can use here in the US?
Yeah,
Big
there's
topic.
so many things to learn from others when you're looking at something this new and novel. And some will be directly applicable to the US and others won't. So I was considering this, and I guess I would go back again to collaboration. And I know I mentioned that previously, but it really can't be emphasized enough how important that is to succeed in something this complex, which is really building a brand new energy system. So collaboration with government, I think there was some discussion just then around the transportation sector, and but I think this applies more broadly as well. The incentives and policy to build and sustain a hydrogen market demand is key. So this is not something that I see being solved within this initial funding opportunity announcement. It's going to require ongoing dialogue throughout the project phases as the hub concepts and commercial models mature towards final investment decisions. So there's some policy and incentive tools to build market demand and share that market risk that were utilized or being considered in the UK and other European projects. Such as contracts of different subsidies or implementation of merit order, which prioritizes the deployment of low carbon products. That might be useful tools for the US, along with a number of others. So some issues and challenges are going to be common among all the hubs we're talking about in the US, and others will be unique based on the specifics of that hub and region. In the UK, they established bilateral sector development working groups, which engage together across industry and users and government to navigate those challenges. And collaboration with communities was also a key importance, which I see being really relevant here in the US as well. So the importance of working with host communities and listening to their questions and concerns, and working together to make that transition to creating good paying jobs that results in really positive economic ripple effects throughout the region. The other area that was a big focus in the hub we're working in the UK is around risk management, because these are really first of kind projects that are also building new markets. So the associated technical execution and commercial risks requires a really high focus on project deliverability. So best in class developers that have experience in comparable projects, and market innovation is critical in comprehensive risk identification and mitigation processes that are really actively managed by the proponents. And we saw in the UK there was a really high level of, or an ongoing high level of oversight by the authorities there around that risk. Because really, to galvanize the public acceptance of a hydrogen-based energy system, the hubs need to be delivered successfully, safely, and efficiently. So failure of any of these hubs could really stall the hydrogen economy in the US. And we wouldn't see the benefits of decarbonization or any of the economic opportunities. So probably those are the two areas, collaboration and risk management, that really stand out for this, where we are right now in the US.
Yeah, I'm taking notes furiously here. I'm going to go off script because you're bringing up a bunch of issues that I think are clearly very, very relevant. Collaboration, risk management. You also mentioned the role of government, which is something that Colleen mentioned as well. So I'm going to open this up for all of you. We can maybe try to unpack all those points. But if we start with the role of government in all this, what is the role of government? How can they best help the industry?
I mean, to start off, I completely agree with Stephanie. We can't just be kind of a one and done kind of thing. I think that's happened in the past already with some of the smaller demonstrations where they operate for a year or two and then the funding dries up and then they're just sort of stranded assets. So I think that's the last thing we want to see happen with these hubs. They need to go on beyond the life of this initial funding period, whatever that looks like from a government support perspective.
Yeah, and I can jump in here. I think there's a few areas. One is, and we've talked about this a lot, but it requires that market transformation mechanism from government that we've seen other emerging technologies have. That's really what this funding is intended to do. But it has to get into that demand side. It has to get into areas that really haven't been considered yet, because it gets very, very complex very quickly, because you're talking about, trying to deploy new technologies in a fleet for a transit district somewhere in the country or something along those lines. You have to figure out how you're going to help, transform that market and close that economic delta so that it's a feasible thing to do. There's the regulatory side of it as well, right? In terms of the distribution of this, the pipeline, the rail, the trucking, what have you. That's going to require a lot. We've seen a little bit of this in Europe with respect to trying to, use hydrogen in, pipelined into residential neighborhoods for heating purposes and such. There has to be a lot of understanding around that and make sure everybody's comfortable with the safety aspects of it, of course. And I think that's important. And then I think that the last one that stands out to me is there has to be a planning component to this. Nobody really knows what a hub would really look like. And if you're talking about a kind of a hub and spoke model, if you're looking at multi-states, you're going to have probably to some degree some centralized production site and then some smaller production sites that are scattered about a given region, depending on how large it is. What does that look like? What is that going to look like in people's communities? Where do you site these things? We've seen a lot of emphasis on environmental justice issues that have to be factored into this as well. So it gets so complex so quickly here. But government, I think, will play a huge role in helping to kind of provide some clarity, guidance, and also just some vision for some of those aspects I just mentioned.
That's great.
Yeah, and I just reemphasize some of the comments that were made around the need for both investment in the infrastructure cost to reduce the infrastructure cost and ensure that we can scale, but then also to reduce the cost for end use consumers. What we hear from a lot of consumers is we really want to be clean. We have sustainability goals. We want our products to reflect those sustainability goals and our contribution to decarbonization, but at what cost? So that's one of the bigger challenges. And the other element that I would raise as well is that we're talking about a deployment hub here, and not really an R&D hub. We're talking about trying to deploy large-scale infrastructure, and that concern about stranded investment is a significant one.
So I'm glad you brought up customers. I had a question here for you, Colleen, about customers specifically. So Constellation, you're brand new, but not really. Provider of electricity and gas and solar in some areas. So you really have touch points in a lot of industries or segments of the industry, and also have a direct relationship with energy customers, right? So how do you think on your corporate strategy? So part of your job is thinking big, right? How do you think all this, the hubs, the synergies between the industries, the network, how is all this going to affect energy customers, or is it going to affect energy customers? Are you guys factoring them in when making these long-term strategic decisions?
Yeah, that's a great question. And long-term, and in some cases, subject to technology advancements, hydrogen can support, as we've talked about, the decarbonization of what is either hard to decarbonize end uses or hard to electrify end uses. So for both energy consumers in residential markets and in commercial and industrial markets, the hub will help to advance the infrastructure and the technology to help realize the decarbonization value of the hydrogen. But it's also important to recognize the interaction between energy markets and the hydrogen market here. So when we think about energy demand, it fluctuates significantly throughout the day and across seasons. So when we're considering the long-term decarbonization goals of the country, we anticipate that there's going to be a significant development and growth in clean energy resources to support that transition. That increased amount of clean megawatts will come onto the grid and help to support and decarbonize across the value chain. So that will happen both through electrification opportunities, but then also using electricity to support the production of hydrogen to decarbonize other hard to decarbonize sectors. Even today, there are periods when the clean megawatts are not being utilized because production is greater than demand, and that will grow over time. So this opportunity to use clean megawatts to support decarbonization is going to be a significant one. And it's frankly just imperative as part of our decarbonization objectives as a country.
That's great. Any other thoughts from the panelists on this point?
I guess I'd like to go back to what Stephanie was saying about collaboration, and a few other panelists have mentioned it as well. I think it's hugely important for multiple reasons. One is, as we've talked about before, the people who are providing the energy are not necessarily the ones who have the end use case. And so you really have to connect all of those things together in order for this to work, and get them all kind of thinking about the same project at the same time. So that's where I think the coordination with the hubs can help as well. And then the other point I wanted to address was the community aspect. I completely agree with that as well. You have to sort of get public acceptance, and be willing to listen to and address people's concerns, especially with the amount of either misinformation, partial information, sound bites that people latch on to, things like that. I've heard things like, well, burning hydrogen makes NOx. Well, yes, it can, but it doesn't mean it has to be that way, not if you design the burners correctly. There's a comment in the chat about the EDF report about hydrogen leakage and it being an indirect greenhouse gas. That's true, but it requires very large leakage rates. Does it mean we should just indiscriminately pump hydrogen into the atmosphere? Probably not, but does it mean it's a problem that can't be dealt with? Also probably not. So I think there's things that we can do if we think about them wisely, but we have to be listening and considering those different things.
Great. Other thoughts on community collaboration, engagement as a whole?
Yeah, I saw a comment in the chat kind of flash up about the labor force and workforce development, which I think is a really important piece of the environmental justice value for the hub. The opportunity to create clean energy jobs, train a new workforce, and expand on our existing workforce capabilities focused on diverse and underrepresented communities. So I think that's a really great opportunity as part of this hub as well.
So, sorry, someone was about to speak, I think. No, I just wanted to follow up on the workforce. So I know it's been a big topic of conversation in the fossil industry, nuclear as well. Do we have the right workforce to drive us through the energy transformation? Is this something that you're already seeing? Do we have a problem there, or can we, or are we all set? Or do we have education or great training needs?
Yeah, well, I can jump in here maybe. I mean, I think the answer is yes and yes. We have great workforce out there right now in the trades. We've worked with a number of our union colleagues to have them understand what the potential opportunities are for them and their membership, and I think they very much understand that. But we still need to figure out how to get more people into the trades and train folks to really kind of operate and work at a very, very high skill level here. I think the opportunities are frankly endless from my perspective in this space. I know just from our being an industrial gas company with what we do, we're in constant need of highly skilled workforce, whether they're welders, electricians, sheet metal workers, truckers. It really has the potential to have a significant multiplier effect on the economic opportunities for a skilled workforce. So I think what we have is great, and we're going to need way more of that down the road as well.
Yeah, I think that point about just the diversity of skilled workforce needs as well is an important one, that it's not just people to work in the hydrogen economy, but it's people to support the development of all of the end use demand, the new growth of new markets, growth of new clean energy products and clean energy developments. It's all of those different areas of focus that provide a significant opportunity. So there's that multiplier effect given the need for collaboration, but also the engagement of so many different sectors and so many different industries to support the development of the hydrogen economy.
Yeah, and I agree with both of those. We need engineers for sure, but we also need those technical trades. It can be very hard to find technicians, for example. They're sort of a dying breed almost. So getting more people trained in those kind of practical skills as we go forward is going to be very important.
And I think this brings back that word that keeps coming up again, the collaboration. So for each sector in each region, it's going to be important to do that needs and skills analysis and work with the local unions, universities, colleges, and et cetera, to fill any gaps to make sure that they're ready.
That makes sense. I'm going through the chat here to see if there's questions from the audience that we haven't touched upon in the last few minutes we have here. Let me see what else we have that might be interesting. Sorry, should have been more prepared for this. So there was actually an interesting question here about the hubs jump-starting the growth of the market. So I'm going to read this. The U.S. has a major hydrogen industry without hubs. The hubs should jumpstart the growth of the market. Aren't stranded assets at the end of the hub cycle evidence of hub failure?
I guess I would say it depends on how yes, I would say so. I think if they're rolled out successfully, then they should jumpstart the growth of the market. But I think that planning phase that they've now put in is very important, because having that time to really lay out what the whole hub should look like, rather than just saying, here's the money, go, will help to form much more logical hubs.
Yeah, and again, what's produced today and consumed today in terms of hydrogen is really by and large in the industrial space. That's not going to go away. That could actually continue to grow as manufacturing and the kind of global economy shifts, and companies are onshoring again, and maybe perhaps trying to avoid supply chain issues in manufacturing in more places closer to their customers. You're going to see more hydrogen demand in the industrial space, but the mobility and in the energy markets, it's still needs to emerge. So I think that there's a tremendous opportunity here for us to really leverage what we do today, leverage the new hub model, and ultimately not have stranded assets, at least in terms of the hydrogen production distribution, if we do this the right way and we do this in a pragmatic method that's thoughtful and really addresses the specific needs to each individual region.
Yeah, I think one of the metrics for success that the DOE has laid out is the scalability of the hubs and the ability for them to scale over time. So I think the corollary of that is the failure of the hubs is the inability to scale. So I think it's maybe less a risk of stranded assets and more a risk that we don't provide kind of the longevity of the market, and we're not able to spur that longevity and the continued growth of the market to support those investments long term and support the scalability over time.
Yeah, I also think an important aspect of the hubs is the diversity that they're trying to put in, because I think what we've seen in a lot of different applications is to the customer and to the operator, the proof is in the pudding. So they want to, it's, show me that it works. It's hard for people to say that they're going to be the first in an application, and so to have the government support to help fund that first of a kind really helps show that, yes, I understand this technology works and this technology works and this technology works, but show me that they all integrate together seamlessly and I'm not going to have issues.
Interesting. We have 5 minutes left. We have another interesting question here. How do smaller companies connect with your larger companies to provide support for the project success beyond the DOE hydrogen matchmaker? So how do we incorporate the smaller companies into these large hubs, right? Or large companies that participate in the hub?
I'm sure kind of across the board, Neil and Stephanie and Kathy are getting calls from folks on a daily basis, or getting inbounds from folks on a daily basis. And I'm sure similar to us, they're not, turning down any conversations around people who want to support collaboration around the hydrogen hubs. So I think it's a matter of really identifying the right folks for outreach, which I think all of these folks on the phone can make those connections and make that a collaborative effort. I think we all recognize the collaborative need to bring both large enterprises and small players into this effort together. And I'm assuming, I don't want to speak for everybody here, but I'm assuming they are the right people to make connections internally. But
yeah, happy to do that. And yeah, I haven't seen anything other than inclusion happening anytime anybody has reached out. I think this is such a big effort and a complicated effort that it does require everybody to be pulling in the same direction here. It does raise an interesting issue of who is the convening entity for some of these hub efforts, and we're starting to see that crystallize a little bit. Not everybody knows exactly now, including us sometimes, but we're very happy to kind of do what we can to make sure everybody who has an interest in supporting a hub in a region is connected.
Yes, I fully support what Colleen said, and certainly anyone that's interested in the area that we're active in, they can reach out to me directly.
Perfect. So we have 3 minutes left. I don't want to go over. I'm going to give each of you the opportunity to give the audience one last thought, anything you want us to remember when we hang up from this webinar, anything we haven't discussed and that you're interested in us knowing about. So this is your last chance for that one little thing, one takeaway that we'll take with us the rest of the day. So I'm going to start backwards on my screen with Colleen.
Yeah, I think we hit on a lot of different good topics and takeaways today, but I'll just end it with the need for collaboration and investment.
Stephanie?
I think Colleen stole my thunder because I was going to say similar, which is the need for collaboration in a way probably that a lot of our organizations have never done before, which is across so many sectors and different organizations to spur that investment, because it is going to require a tremendous amount of private investment to achieve.
Neil?
Yeah, well, I'll stick with that theme because I think one of the biggest challenges we see is how all this comes together commercially. And that's a challenge because we are all experts as companies in the areas that we operate, but we don't know everything. And as somebody said, and I apologize, I don't remember who said it, this is really reshaping the entire energy market and how we consume energy and produce energy. So there's a lot of unknowns here. So to the extent we can get everybody involved, there's many as possible to collaborate, the better the effort's going to be.
Kathy?
I guess I would say as a scientist, one of the things that's the most exciting to me is there's so much opportunity. I think we know enough to know that there's a lot of things that we can do to advance these technologies. It's going to be a lot of work because the work hasn't been done yet on our specific technologies and materials, but we see the pathway and we see the potential, and the fact that there's all this investment happening right now. Really, I think finally, for a lot of us who've been in this industry for a while, we can finally really see that tipping point starting to happen.
Wonderful. Unfortunately, we are out of time, but I hope you agree with me that this was a truly excellent panel. Count me in to moderate you guys anytime. I learned a bunch. So I really want to thank you all for participating today, and the audience, of course, for attending and listening to us. We will be in touch to address any outstanding questions or follow-up that may have shown up in the chat and that we haven't addressed. And with that, again, thank you so much for joining us, and hope you have a fantastic day of your day. End of your day.
Thank you so much.
Thank you.
Bye, everyone.
Thank you.